Greetings to all viewers. This is Professor Ankit Singh. We'll now move to the next type of numerical, that is on grade compensation. Let us have a look at the question first. While aligning a hill road with a ruling gradient of 6%, a horizontal curve of radius 60 meters is encountered. Find the grade compensation and the compensated grade at this curve. Okay. So what is given here? Ruling gradient is 6% and radius of horizontal curve is 60 meters. We know that the formula for grade compensation expressed in percentage is given by 30 plus r divided by r. The value of r given in the question is 60 meters. So 30 plus 60 divided by 60, we get 1.5%. Also, the maximum limit of grade compensation, the formula is given by 75 by r. So 75 by 60 is 1.25%. Okay. So although the grade compensation that we obtained, it was 1.5%. Okay, but since the maximum limit of grade compensation we got 1.25, hence we can only provide a grade compensation of 1.25%. Okay, hence therefore provide a grade compensation of 1.25%. So compensated grade is equal to ruling grade minus grade compensation. So this is ruling grade is given in the question as 6%. So 6 minus 1.25, it is 4.75%. Okay, we'll now move to the next question, that is numerical on vertical curves. So this first numerical is on summit curve. The question is as follows. A vertical summit curve is to be designed when two grades plus 1 by 50 and minus 1 by 80 meet on a highway. So this is a positive gradient and this is a negative gradient. The stopping side distance and the overtaking side distance required are 180 and 640 meters respectively. But due to site conditions, the length of vertical curve has to be restricted to a maximum value of 500 meters. Okay, so the length of curve cannot be the higher value than 500 meters. Okay, calculate the length of summit curve needed to fulfill the requirements. Okay, of the stopping side distance and also overtaking side distance, or at least intermediate side distance. Okay, so let us move to the solution. What is given to us? SSD, that is stopping side distance, is 180 meters. Overtaking side distance OHD is 640 meters. Maximum length of summit curve as per the question, due to site conditions, it can be only 500 meters. It cannot be more than 500 meters. Gradients are plus 1 by 50 and minus 1 by 80. So deviation angle would be the difference between these two gradients. Okay, so capital N equal to plus 1 by 50 minus of minus 1 by 80, that is 13 by 400. Now for the requirements of SSD in the first condition, if we assume the length of curve is greater than SSD, okay, which is 180 meters, the formula that we use is L equal to ns square by 4.4. The value of n is 13 by 400, s is 180 square, okay, divided by 4.4. Solving this, we get 239.3 meters. Now since this value 239.3 meters is greater than 180 meters, okay, so our assumption which we made is correct. Hence the length of summit curve required is 239.3 meters, which is less than the prescribed maximum limit of 500 meters. Okay, so for SSD condition, the length to be provided is 239.3 meters. Now the second condition is for requirements for OHD. Now as the length L of the summit curve is to be restricted to 500 meters, which is less than the required OHD of 640 meters. Since in the question it is given that the OHD is 640 meters. So obviously the length cannot be greater than 640 meter. Hence we assume the condition L is less than OHD. Okay. So for this condition the formula is 2s minus 9.6 divided by n. The value of OSD is s here, okay, so 640, and n is 13 by 400. Solving this, we get 984.6 meters. Now this again is still greater than 500 meters, okay, which is the limit. As the length of summit curve obtained is higher than the OSD, that is 640 meters, the assumption is not correct. Okay, so this condition in as a whole cannot be satisfied. Also, in the problem it is specified that the length of summit curve is restricted to a value less than 500 meters. Therefore, it is not possible to provide an OSD of 640 meters at this summit curve of length limited to 500 meters. Since we cannot provide OSD, what we do is we check for ISD. Okay, so we attempt to design for ISD. We know intermediate side distance or ISD is given by 2 into stopping side distance. So 2 into 180 will give us 360 meters. Now for L greater than ISD or 360 meters, we have the formula ns square by 9.6. Substituting the values n 13 by 400 and s as 360, and solving this we get 439 meters. Now since the obtained value is greater than 360 meters, hence the assumption is correct. And also since 439 is less than the 500 meters, okay, therefore we can adopt this value. Therefore provide design length of summit curve L equal to 439 meters, which fulfills ISD condition. Okay, we'll now move to the next problem. This problem is on valley curve. The question is as follows. A valley curve is formed by a descending gradient of 1 in 25 meeting an ascending gradient of 1 in 30. Design the length of valley curve to fulfill both comfort condition and headlight side distance requirements for a design speed of 80 kmph. Assume allowable rate of change of centrifugal acceleration, that is capital C, is 0.6 meter per second cube. So what is the given entity over here? Velocity, design speed is 80 kmph. Downward gradient n1 minus 1 plus 1 by 25 followed by a positive gradient plus 1 by 30. So deviation angle would be difference between this minus 1 by 25 minus of 1 by 30. So we get minus 11 by 150. Okay. Also, since velocity is given in kmph, we can convert it into meter per second in order to use it in this specified formula. Okay, or we can also use it for the formula if we just convert this formula into in terms of kmph. But here what we're doing is we convert kmph to meter per second. Okay, so 80 kmph, when you try to convert it into meter per second, you need to divide by 3.6. So it is 22.2 meter per second. Now for the first condition in valley curve is for the comfort condition. So L is given by 2 into nv cube divided by c the whole raised to half. Okay, substituting the values over here, n is 11 by 150. Okay, keep a note that we do not use the signs. Okay, signs over here. Okay, we always consider positive sign or plus sign for capital N. Okay, so n is 11 by 150, v is 22.2 in meter per second cube divided by c, it is given as 0.6 meter per second cube. Okay, whole raised to half, we get 73.1 meters. Now the second condition, valley curve length for headlight side distance. Okay, so here we can assume headlight side distance we know is equal to the stopping side distance. And what is the formula for stopping side distance? Neglecting the ascending and descending gradients. Okay, here you need to neglect the gradients. So what would be the formula for SHD without gradient? It is Vt plus V square by 2GF. And for SHD, standard values of reaction time is 2.5 second. And for this speed of 22.2 meter per second, F is 0.35. Now substituting the values in this equation, 22.2 into 2.5 divided by 22.2 square divided by 2 into g is acceleration due to gravity 9.81, F is 0.35. Solving, we get 127.3 meters. Okay, this is what SHD, or the SHD, or which is equal to the HHD. Now in order to find the length of the valley curve, the formula is this. Now when do we take this formula? When we assume L is greater than SHD. Okay, now we assume that L is greater than SHD. So for this condition, the formula is L equal to ns square by 1.5 plus 0.035 into S. Substituting the values, okay, N is 11 by 150, S is 127.3, that is nothing but the HHD that was obtained, and S is also the same. Solving this, we get 199.5. Now this is greater than 127.3, hence our assumption is correct. So this is the value. Okay, now the valley curve length based on the headlight side distance being higher than that based on comfort condition. Okay, what we obtained here is 199.5. Based on comfort condition, it was 73.1. Hence we adopt the greater value. Okay, being higher than that of the comfort condition, the design length of the valley curve is 199.5 meters, or it can be taken as 200 meters. Okay, thank you.